Hello, with this video I'm going to show you how to embed in our application a very special hardware from the manufacturer's Blum. It's Aventos hardware that is quite special because its position is depending and relative to the cabinet height. According to Blum's paper documentation, the catalog, I can notice here that depending on the cabinet's height, there are two typologies, one based on 480 to 549 and the other from 550 to 1040. Therefore, to make it parametric, I will need to create a lot of parameters at the level of the cabinet manager. Well, it means now that I need effectively to create four variables in my cabinet parameters. These are copies from the book of Blum. The first one is VALH, the second one VALX, the third one is H, and the fourth one is a bit more complicated. It's called the HM base, and I need to enter a value that is also just a copy of the Blum's catalog. So I'm sorry to repeat it, but actually those variables are a carbon copy of the Blum's catalog. Now I need to insert in my application and import the hardware, so it's directly in 3D from Blum. This is called a reservoir, and I need to immediately change it from ACIS to Parasolid, because otherwise later you might have problem in the CAM system. I'm going to import now the second part, which is the M-base of my hardware. This must be also automatically changed from ACIS kernel to Parasolid. And of course, it will need to be somehow positioned. So with the help of the tribal, I'm going to rotate it first at 90 grade. I'm going to move it forward. I'm going to rotate it again. And I need to center my AHM base here in the right axis. And this can be done very easily with the tribal. Now I'm going to assemble both parts to make only one assembly, because it's only one hardware in my virtual library. And I rename it to the corresponding Aventos name. Since my M-base must somehow automatically move downward, I can achieve this by creating a new variable. So I need to do this, and I create a pose M-base variable. I let it to 0 at this stage of my design. Now I'm going to assign it to the part, and to do this I need to select the part, choose for part properties, select the anchor bookmark, and I'm going to simply write before checking I just check show formula, and I'm going to simply write the name of my variable here in this field, and this will manage actually the distance from the anchor, the distance of which the plate must be positioned. Okay, so far it seems to be good, but not yet actually, because I realize here that the plate must somehow move forward. According to the documentation, I know that the little extrusion there, I know it is at 37 millimeter from the front edge of my cabinet. So I just move it first backward with the tribal, and then I move it forward with a value of 37 millimeters. And I'm sure now that it's in the correct position. I can save now my new hardware in my hardware library. Okay, fine. This my cabinet. I need to drop now my new hardware on the left lateral, and so I select it in my virtual hardware library. This is it, the Aventos hardware. I set the quantity on 1, and I just validate and look what it looks like on the cabinet. Apparently, okay, obviously it must be rotated somehow to be properly positioned, and it must be rotated around the for sure the blue arrow, and probably around the red arrow or the green arrow, and that is very easily done with my wizard. It's very user friendly. Looks good, but so far is my hardware not parametric at all. So if I look at the table of parameters of my cabinet, there are a lot of them. It's quite impressive. I don't know where to find my line and so on. So I use a small trick. I just edit my hardware with the add-on properties, and I enter a fantasy value like 152 in the rows field. And if I get back to my table of parameters in the expression column, I can easily spot now, okay, 152 millimeter, I know it's my line. I know that this is the line I have to work with, and I'm going to enter H_1 because it must take that value. And as you can now realize, the hardware has been moved downward somehow. Okay, it's not yet parametric. You know that somehow the part, the HM base must also automatically move somehow. So I toggle back to the table of parameters and I target my pose M base variable, and I assign the HM base value. And here I realize that effectively my M base has moved downward in the right direction. At this stage, the hardware is still not parametric, because remember that its position is relative to the cabinet height. So somehow I will need to introduce a function like if, then, else, or whatever. And yes, I'm going to write something like if the cabinet's height is above such a value, then my variable should be set on, and so on. So I'm going to write it like we do in many applications, and also in Excel, for example. So this is the way I'm going to do this. Okay, nice. Now it's the big test. I'm going to edit the dimension of my cabinet. I set it to 540. I drop the edit feature to recompute everything, and I toggle to my table of parameters, and there effectively I can realize that the value has been updated, so it's working correctly and properly. So this is what my cabinet looks like. I'm just going to hide the doors and verify that everything is okay inside. Okay, I hide the door. Presence of the two hardware, maybe one shelf should be deleted. We have the 4 hinges on top. And if I look at the back of the door, there should be also 4 more hinges. And if I toggle to wireframe view, I can verify indeed that everything seems to be right. That's it. We have now a fully parametric cabinet with Aventos, and it can be now dropped in my catalog for use later.